Hello everyone, welcome to this session of Exam Helper teaching Module 4 Microcontrollers and Embedded System, 6th semester of engineering. So I have started with the Module 4 because right now I'm preparing for my internals and for final exams. So I thought of starting from this topic. Anyhow, you can browse whichever topic you want and see that video first. For me, this is the first video which I'll be uploading. Later on in the playlist, we'll be having a structured and ordered format. So the first topic we can see in the syllabus copy 2, module 3, we have embedded system components. So there is embedded system versus general computing system, history of it, classification of it, application of embedded system. That's module 3. So starting with module 4, we have characteristics. This is one topic. First, we'll be studying only characteristics. We have quality attributes of embedded system. Quality attributes are nothing but this. These both are nothing but the quality attributes. You just have few lines for this, and then you will be explaining this and this separately. Applications like that automated ADS, that cars, automatic driving systems in cars, washing machines, air conditioners, etc. Domain specific in the sense the same thing. Hardware and software co-design and modeling program modeling, sorry. So you can actually skip one topic in this entire module, like you can skip this one or you can skip any just one thing, because usually in module 4 they'll be asking all the questions, so they won't repeat same topic twice, right? So the probability of one topic not to be asked is good. Even if they ask, you can simply skip that and go to the second or option question. So whenever they ask you about the characteristics of an embedded system, you just have to start saying, unlike general purpose computing system, like you have to always say with comparison to general purpose system, the characteristics of embedded system are very unique, and there are 6 characteristics which are mentioned in the textbook. So you have to follow only these 6 characteristics only. So we have application and domain specific, reactive and real time, operates in harsh environments, distributed, small and weight power concerns. Don't worry, I won't be just reading over here. I'll be explaining as well. Here I have marked highlighted the important things which we need in this session. So for first application, it is application and domain specific. Here, each embedded system is designed to perform a set of defined functions, and they are developed in such a manner to do the intended functions. So here, in the sense, they are saying that whatever each embedded system, so there are different types of embedded systems, right? It's not like they're just one embedded system which every device is using or something like that. So for every purpose there is different embedded systems, and they have said here that for each it is designed for particular task in such a manner that for example, if you take an example of microwave, it is prepared to for heating food. So you can only heat food in that. In some microwave you can also cook, like for cooking purpose, but basically what it does, it's just heating, right? And if you have to take AC for cooling purpose, so you cannot use the embedded system used in microwave to do in air conditioners. That's what happens. You cannot replace the embedded control unit of your microwave oven with your air conditioners embedded control unit. If you see the notes which I prepared using the same textbook, it is just like what to say, filtered part of the textbook. So here they speak about application and domain specific. If you have to understand small term the description, it is they are designed for a specific application or domain, like specific domain or specific application, and they are not general purpose. You have if you have to understand more in detail, you can see single functionality in the sense application for specific purpose, like see one specific task repeated, like microwave always heats food, air conditioner always gives AC and all. Then we will go with the second application, reactive and real time. Embedded systems are in constant interaction with real world through sensors and user defined input devices. Uh, any changes happening in the real world, which is called an event. So you have to remember what is event is nothing but changes happening in the real world are called as events. embedded system produce changes in output in response to the changes in input. So they are generally referred as reactive systems. Why they are reactive? So now we understood. In this thing we have called them as reactive and real time. Why they are reactive? Because based on your input, it will generate the particular output. So if your input changes, the output changes as well. Or you can see here they have written in like reverse manner. Changes in output are a response to the changes to the input. If you want to understand in simple terms, you can simply understand that it is if you change the input, the output will also be changed. Nothing much. And the system should respond to requests or tasks in a known amount of time. We'll see the things over here. See, reactive and real time, it responds to the external events in real time with time constraints. So you understood they are reactive. What is the meaning of reactive? That the input, if the input changes, the output changes, and to which reactive it is. So it responds to the real time, events. What are the real time events? They are nothing but the data or all the things which is collected by the sensors. It's mentioned over here. You can see where the sensors. Somewhere the sensors were. Yeah, see, they are captured by the sensor or input devices. So, any changes happening. So, the changes happening in the real world are captured by the sensors. These things are responded by the reactive system. So, they are called reactive and real time. So, response to an external event in real time with time constraints. You have to always remember it is time constraint. Same way, if you have to see in this thing, reactive and real time must respond to external inputs or events, likely sensors data with specific time. Example, airbags in car must deploy within milliseconds during a crash. So as soon as there is a crash or something, the airbags should be deployed within milliseconds. So here, the real-time events sensor, they sensed an external event that is nothing but crash. So as soon as it sent within milliseconds, the system which is reactive, it responded to this external event which was collected by the sensor, and what task did it perform? Airbags were deployed within milliseconds. You understood, right? It's very simple. If you take an example of a car crash, so the car crash is nothing but is an external event which is captured by the sensor data. Now, in response to this real-time event, what the system has done, what the embedded system does is they deploy airbags in the car. So this is the reaction which they have done. Deploying airbags is a reaction. The external event is the crash. So how this airbag deployment is responding to the external event that is crash is known as reactive and real time. This is one of the application. I hope you understood. The third application operates in a harsh environment. In the sense, it's basically like robustness, which will also be there in the quality attributes. So robustness is nothing but even in harsh temperature conditions, in every if they have put to like push to the limit, it should still perform. So they have taken the example of dusty or high temperature zones or an area subjected to vibration and shocks. If the systems need to be deployed at a high temperature zone, then all the components used in the system should be of high temperature gate. Cannot go for a compromisation cost. So in this particular thing, if you think like it's too much cost, I have to go for a cheaper thing, then you'll practically be, you know, compromising in this major application, and your embedded system won't be that good. See here, often functions extreme temperature, humidity, dust, etc. That is the nothing but small applications. So for that, they have not mentioned properly anything. See, few AI generated answers will be like this, like they'll give 8, 9, 10 applications, but this is just for our own understanding because we have examples over here like code and data stored in one chip. Anyways, we don't want these things. We will move to the next application, that is distributed. I hope you understood what is this third application, operation harsh environment. It should be able to operate in specific environment. A specific environment can also be like in Arctic regions. You have there are many bases and scientific research space in Arctic region also, like there's everything is like completely cold, -degree, but still the systems are working. So it has to be operating in such an environment. If you systems are basic labs and any research facilities are deployed in how to say, deserty region, in deserts and stuff, there's too much temperature and too much dust as well, so it has to, operate in such specific condition as well. In some, it like under marine, though it won't be inside the water, but still it is far from the, surface. Sometimes it has to deal with, rain and everything over like that. So for example, your traffic signals and all, even they are embedded systems, like they show your timing, right? At what time it will be a red signal, green signal, etc., etc. Distributed means that embedded system may be a part of larger system, for example automatic vending machine. So you just have to understand in distributed in the sense, for a particular, like if they have taken vending machine, ATM, automatic teller machine, ATM machine, and supervisory control and data acquisition, that is one type of another device, in which there are multiple, components or control units. Each is different, but they all work together to perform a particular task. For automatic teller machine, you have a card reader, you have that entry buttons, you have screen for selection. All are different, units, but what they do, they perform together. What to do? Either to, like, say, like withdraw the money or deposit the money, like that. If you see in this nodes, distributed systems, some memory systems are distributed with multiple interconnected nodes. So basically I said multiple units are there. What they do, they perform together to execute one particular task. So it's nothing but different units, you can call them as different nodes are interconnected, you know it's very simple, right? Different nodes are interconnected, but to perform different, unique tasks. Though they are different, the nodes are different, they are different, like completely different if you compare them, but still they are performing together to perform one single task. If we have to see, if larger system function as a part of larger, for example, engine control unit in automobiles. So engine control unit, multiple units are there, but they perform one task itself, like that. You also have, in foreign countries, like if you put coin, you will get juice and all those. It's automatic vending machines, right? You have input like a coin reader. You have a dispenser for that. Which particular, see if they have to select which juice they want, right? So that unit is different, like input unit, and then the particular juice which you selected was then deployed and given as an output. Then small size and weight. So product aesthetics is an important factor. So they are talking about aesthetic in the sense, it should be small. They are preferring small size and small weight because they look beautiful. Like they have, people believe in the face small is beautiful. So small size. So whenever you are purchasing any product, you try to research about it. What's like battery performance, Snapdragon, RAM, ROM, everything like processor. So at that time you see, like you don't need a phone which is like completely heavy, right? Like a dumbbell or something, the weight of like that. You don't like all those things, and you don't like the style which is like, but keypad phones nowadays, who will use button phones except for old peoples? The size of the phone, you don't like too small, but you like big. It shouldn't be too big like your tablets because you cannot carry them everywhere. So it has to be a good size like your Samsung phone or iPhones size of that. Weight should be also within, like proper weight. It shouldn't be like if you use for a long duration, it shouldn't, cause any strain to your arm. So it's all about that itself. Most of the application demand small size and low weight products, and it's just like, how you prefer. It's based on your preference. Small size and weight is nothing, but physical size and weight are constrained in the sense what shouldn't be too much, it should be like less. Power concerns. So power concerns are very important, like embedded system should be designed to minimize the heat dissipation by the system. So there is high amount of heat demands, the more higher amount, like if the system, like for example if you're using your laptop for a long duration, so it produces heat obviously, but to counter that, there should be a cooling system as well. So the production of high amount of heat demands cooling requirements like cooling fans, which in turn occupies additional space and make the system bulky. So you don't have to, you have to build a system in such a way that it is not even bulkier, it is compact, but yet provides all the, features like dissipation of dispatching of heat, and providing cooling system and etc. In this notes, power consumption is critical, often battery operated. It's too less, but all you have to mention is power consumption is very important. Like higher the power consumption, the lower the battery life it is. The power consumption in such a way that it should give a long battery life. See, that's what they have written over here. Uh, Reliability and stability. See, should run for long durations without failure. Systems are tested for robustness and fault tolerance. You can practically write this key point for running for long durations for that. So this concludes the characteristics of embedded system. I hope I have explained you in a detailed manner. You can write them for 5 marks, for 10 marks, or for 15 marks. Very easy. Always remember, if you're not able to fill quality like technical terms, take an example and use the same technical terms in the example and just expand it. See, you can take an example of microwave AC for the first thing here, and for reactive you can take that car accident thing. Operates in harsh environment, you can see the high temperature, dust, vibrations. You can select specific region like desert or hilly or cold region. Distributed in the sense what, multiple nodes, but they are interconnected to perform single task. And then small size and weight, it should be physical size and weight constraint, in the sense it shouldn't be too much large in size and too much high in weight. It should be friendly for the user friendly. Power concerns should run for a long time. Shouldn't, like, you can take example of laptop. If you use gaming laptop, especially if you use for a long time, not for long, if you run games, you can see the system is like the temperature of the system rises, but you can hear some cooling noise, like fan noise in your gaming laptop. That's nothing but it reacts to that high temperature. The cooling system reduces the temperature so that you can perform, your laptop can perform properly. The next topic is the quality attributes and the embedded system. I will see this in the next video. Also, in my notes which I had prepared, there are detailed, sessions for the characters, each specific characters for that application, and to make domain specific one. We have the reactive and real time, how it should be deterministic, with an example. You can just see. Although I'll be providing all these notes, in the description of the video link. Each video will have, like entire module note itself. So operates in harsh environment. Distributed, see, they have taken the example properly. Automatic vending machine, ATM, small size, product aesthetic. Mainly, you have to talk about product aesthetics. Power consumption is nothing but the power management. In few devices, there are ultra low power mode, sleep mode, like airplane mode, like driving mode, reading mode, like all power concerns. Like based on those profiles, it does all those things. So this is, I just wanted to like quickly add this part in the like video. That's it.